Alright, we're going to be doing 6.1.3 exponents. This was a previously recorded video that did not have sound, so my voice and what's happening on the screen may be different, but I'm going to go ahead and talk us through it. We'll be using the checking problems as usual, and I actually have the study guide on the left. So this is from the study guide. If you don't have access to it, let me know. It was sent to you in an email the first week of school. This just has all the properties and all the exponent laws and what we will use. So we're going to go ahead and do our first problem here. So we have 5 cubed times 5 to the 4th. I want to look to see if I have a problem like that or an example like that in my laws. I go over there and look. Maybe I do. So I found the multiplication law of exponents. So when you have the same base, right? So the same base, we have b and b, or 5 and 5, and they're being raised to different exponents. They're being multiplied. We go ahead and add them. So this is just going to be 5 to the 3 plus 4. They have the same base. It's being multiplied, so we add the exponents. Multiply same base, add exponents. And it's just 5 to the 7th power, and you can plug into a calculator if you want that real answer. And I don't remember. This is why these videos take so long, because I don't stop talking. Alright, so we had the same base, the 5 and the 5. We had the exponents they were multiplying, and we just go ahead and put them together. We follow that multiplication law of exponents. Now, doing number 3, I have a 4 cubed, and then to the 5th power. Well, I have a power law of exponents. Looks like the same thing. We have a base, and we have a power to a power. That's kind of what we'll call it. We have a power to a power. When you have that scenario, it becomes kind of like, but not really, kind of like distributive property, right? Something outside of parentheses, we're going to go ahead and multiply it. So for our example, we have a 3 exponent and then a 5 outside. This could be a 3 times 5. And the base stay the same, obviously. It'll be, yeah, be a 4. To the 15th power. Just multiply. Right, and that's the power law of exponents. All right. Doing number 5, and we have now a division problem or a fraction with an exponent. Well, I have a quotient law of exponents. And what that tells me is that if I have a fraction and have an exponent outside of the parentheses of the fraction, I can go ahead and distribute the exponent to the numerator and the denominator. So it would be 2 to the 6th power over 7 to the 6th power. Then obviously we can do a calculator if we want to solve that a little bit more. That's just using that law, right? So I'm just seeing a problem, looking for something that's similar, and then I want to just follow the steps, follow the pattern. All right, so this next one, we have a 3 to the negative 5th power. So a negative exponent. Well, we have a rule for that. Excuse my yawn. So a rule for negative exponents is anytime we have a negative exponent, like in the numerator, I can just change it to the denominator. Right? So it's on top of the fraction, so I can just flip it, right? Every integer number is always assumed to be over 1. And I just put that 3 to the negative 5th on the bottom and make the 5 positive. If I was given the opposite situation where there was a negative in the denominator, I put up in the top of the numerator. Just change the, oh goodness, I'm sorry. Can't stop yawning, I apologize. He just changed the exponent from negative to positive. Now, if the coefficient was negative, like if the 3 in the original example or the 4 in my example was negative and we had to flip it, we would not change that sign. We only change the exponent sign. All right, so we have the product law of exponents, right? So we have two numbers being multiplied with the same, two numbers being multiplied, surrounded by parentheses with an exponent outside. We can just basically, quote unquote, distribute. That's wrong, but distribute the exponent. So each number gets that same exponent. Now we have a fractional exponent. So fractional exponents, we actually don't have a law for this that I see. That's okay. So we'll get there. Alright, so fractional exponents. So basically, 1/2 power is a square root. That's just what it is. So that there's no number there, like where I just put the 2, that's called the index. Um, we don't write it there if it's a 2. If it's a square root, we don't write the index. But if it's a cube root, we would write the index. Alright, so if it was a 1/3, that 3 would go there. So a 1/2 power is just a square root, and the square root of 81 is 9. So anytime you have a square root, it is just anytime you have the 1/2 exponent, it's just a square root. Alright, so going to number 7, we have 64 times 121 under a radical, a square root. Now, similar to what we've been doing elsewhere, is I can separate these two things. I have a square root of 64 times 121. Well, I can just make that the square root of 64 times the square root of 121. I can basically give each of them an individual square root to keep them multiplying in between, but give them an individual square root. This kind of follows that product law of exponents. And the square root of 64 is 8, square root of 121 is 11, then 8 times 11 is 88. So I can just kind of separate those two things. Now 8 wants us to rewrite the cube root of 7 with exponents to the cube root. It tells us that the index okay, never mind. We're going to do 9 first. So we're going to do 9 divided by 4, both of the 1/2 power, so I can individually give the 9 a 1/2 and the 4 a 1/2. And I know that a 1/2 exponent is just a square root. So the square root of 9 and the square root of 4. I really do apologize for all that yawning. I don't know why. I'm getting overcome. Square root of 9 is 3. Square root of 4 is 2. 3/2. So I use the quotient law of exponents to distribute that essentially. And then I just know that the 1/2 exponent is a square root. Now 10, simplify 4 to the 3rd power to the 1/3 power. This is the power law of exponents. So the power to a power. I just multiply. So it's 4 to the 3rd power times 1/3. So 4 to the 3 times 1/3. Well, 3 times 1/3 is just 3 over 3, which is just 1, which is just 4. Alright, so we just follow that power law of exponents and multiply and simplify. We could have gone from the first step to the last step slightly. I'm actually just going to delete that. We don't need it anymore. Here, if you notice, I took the denominator 2 and I put it here. That's called the index of a radical, right? We normally don't write it. Like I didn't write it over here, right? Because we know it's 2. If there's nothing written there, we just assume the default is 2, and then the numerator went there, right? So the denominator went into the index. Well, my index on this one is a 3, right? Well, if my index is a 3, if I follow the pattern I had down here, it becomes my denominator. And since I have no other exponent here, just like I had none over here with just the 1, my numerator is going to be 1. So I can take this, and this will be 7 to the 1/3 power. All right, that's going to be it for this section. Now, again, this is bare bones. If you need more detail, you need more help, please reach out to me. This is just supposed to be a groundwork thing for you guys to ask me a question. Say, hey, at the 3-minute 24-second mark, I didn't understand this. Cool. We can talk about that directly. All right, just give this a listen first, and then ask me whatever questions you have. Don't just assume this is the end of it all. This is just the beginning. All right, and then somewhere at the bottom, my microphone must have turned on in this video, so you just kind of saw it jumped from my current voice to the previously recorded one. So again, like I said, if you have any questions, let me know.